All right, guys, welcome to another KevCAM night class. Tonight I have Brendan McKenna helping out to answer any questions, concerns, or anything that comes up along the way. How's it going, Brendan?
Good. How you doing, man?
Good. All right, guys, so tonight we are going to be covering 3D iMachining. I'm going to try to show you guys all the tips and tricks inside 3D iMachining. I did have a couple requests to kind of go through all the way from the start to finish of it, so we'll kind of cover adding material into the database, a little bit of review from last week too, but we'll be adding some new machines in there, how to get those added in there, the material, all that good stuff. And these guys, I can't talk, these classes are solely dedicated for you guys, so if there is a idea that you guys have, definitely send that over to us. We do have a submit idea, and we'll give you a free hat and t-shirt. Really want to get these classes going as long as possible for you guys, so like I said, if there's an idea for you guys, shoot them over to me via email, and what I'll do is I'll put my email address just in case you guys don't have it.
Yeah, that's a good thought, Kevin. One of the things that we do try to just kind of explain to people as we go through these meetings, what we're doing right now is we're keeping everybody in what's called listen only mode, and what this does is just kind of eliminates background noise, and but you can still participate and ask questions if you'd like. So about 3/4 of the way down, you'll see a questions pane or a questions window, I should say, in the go to meeting area. So if you want to ask a question, please feel free to type it in there. I'm going to be monitoring that throughout, and if we don't get to your question right away, please don't panic. We'll be sure to get your question answered because we do a Q&A at the end of the presentation. So no problems there, and we'll be sure to take care of those. So I just wanted to kind of
absolutely, yeah. Thanks for covering that, Brendan.
Touch on that.
Yeah,
sure.
Okay, so if you guys are new to the class, what we do is every Wednesday night do a night class. Slowly, like I said, it's just for you guys, and it's ideas that have come across. If you guys have missed any previous night classes, we do have a SolidCAM University channel that I have started. All our night classes are in here. Plus, what I do is I put some additional ones in there once or twice a week. There's some short ones in there. This one's just a 3-minute one, or creating STO holders. That's a 6-minute one. So definitely come to this channel right here. I'll put the link for my channel in there and subscribe to it, so you'll see all the upcoming or all the movies that I do in here. And if you guys have one, like the Spiral Pocket was a requested one, so I just did a quick video. So if you guys have one that you want to see, let me know. We'll add that in there for you guys. And then, like I said, all of our night classes are all in here. If you just come to this channel from all the way from the start to, or from when we started this channel. So definitely check it out. And any questions, like I said, just shoot me an email and we'll get that off to you. So I guess with that being said, we'll dive headfirst in here. Okay, so what I'm going to do is I'm going to kind of lead off of what we did last week to start off with. Last week we did a 2.5D. We'll do a little bit of a recap here. So to activate or to get your material into your database, you're going to come down where you pick your coordinate system and your stock and your target and come down to the iMachining data. Right here you have, right now you might just have 1 or 2 machines in there. To add machines in there, easy enough, just click on the Edit iMachine Database and click the new piece of paper. We'll just label this as test. And it's going to ask you your max RPM, max feed rate, and horsepower. Those are the only 3 parameters that we need to utilize your machine and to add a machine in there. Now, like I said, I apologize, guys. I know this is a little bit of review for you guys that were here last week, but now for material, you guys will have a whole slew of materials in your database. Now, you're going to see a lot of them that just say plain carbon, some pretty blah materials in there. So the best thing I can suggest for you guys is go to the website matweb.com, and I will put the link for this in the chat for you guys too. Is everybody seeing the chat window that I'm putting the links and my email address and all that stuff? Okay.
Yeah, you know, Kevin, I'm seeing it on my end. It looks like everybody can see it here.
Perfect. Okay, so what you're going to want to do is come to matweb.com, put what material you're looking for. We'll just do 6061 T6, and then go ahead and click on the specific material. And we are looking for the ultimate tensile PSI. So we're going to be cutting this part at room temperature, so we have 45,000 PSI. All your materials that you guys cut should have an ultimate tensile PSI in matweb.com. For some odd reason, if it's not in there, just contact your vendor that you get your material from, and they'll be able to provide you with that information. Now, once you have that information, you can come back to your SolidCAM, click on Edit iMachining Database, and then we're going to click on the Material tab. Right here, just hit the new piece of paper, and then you can put your 40,000 PSI in there for material. And that's how you add materials in there. Now, this is the absolute best way to do it. You can use the standard materials that are in there, but by putting your own custom one in there, it's going to get you even more accurate, and it's going to give you a faster cycle time with better chip removal. So, like I said, you guys can use what's in here, but they're pretty stock, and you'll see up here I have a whole slew. I got 4140, 4130, 304 stainless steel, so have a lot of materials in here, and that's kind of what I suggest doing. You know, if you guys are just working with 3 or 4 materials, it's pretty simple to add those materials in there. So now we have our machine. Let's just grab something other than, we'll just grab a BF6. We have our material. We'll just leave it at our 6061 aluminum. And our machining level. Now the machining level is going to be your default level. In here, it's going to, when we start a new operation with iMachining, it's going to bring up the wizard, and it's always going to default to level 8. Now, if you guys are new to iMachining or you guys haven't used it very much, definitely let it be at level 3. And it's a great starting point on there. iMachining, it's going to scare you a little bit the first time you use it just because it's going so fast, but I guarantee you're not going to break cutters. You're going to get a much longer tool life out of your cutter, and it's a lot easier to program, as we'll show you right here. So, okay, so like I said, basically taking the part that we had last week here, and now we're going to go into easy mode using 3D iMachining. You'll see that I already have my part probed up right here. So we'll come into our 3D iMachining now. Now we have 2 different options inside 3D iMachining. We have 3D General and 3D Prismatic. The difference is for your 2.5D parts, you're going to want to use the Prismatic. It's going to pick up all your flat floors, flat walls, all that stuff. Now on our next part, we'll actually get into 3D General, and basically any 3D part is going to be machined out using a scallop. So one big thing to know about 3D iMachining is it's basically a full automated roughing operation for you. You can use it to finish. You're just not going to get the nicest wall finishes in there, but I'm going to kind of show you guys what you guys can do to you know, do a finishing operation on that, or just to use with what you have. Okay, so right now I don't have to pick my geometry. It's 3D iMachining is going to pick it all automatically for you. Basically what is happening here is it's looking at your stock versus your SolidWorks model, and it's going to machine everything off in between. So you can kind of see I have a wireframe or a transparent stock right there. You'll actually see that's what I'm actually clamping onto with my Kurt vise right here. So what it's going to do is it's going to look at the stock, it's going to look at your target, and machine everything up to that SolidWorks model. Now, another nice thing that they added in 2016 is they have the fixture collision protection. So I'm going to leave this off for right now. I want to show you guys what happens, and then I'm going to turn this on. So basically, when you guys use 3D iMachining, don't have to touch anything on the first page. The only thing you guys really have to do is pick a tool. So we'll use, let's use that 1/2 inch end mill. We don't care about levels. And the wizard is where our feeds and speeds are going to come from. Now, this is the feed wizard that I was telling you about. So this is what controls your feed rate, your spindle RPM, angle of engagement, step over, step down. This is what takes all the guesswork out and makes programming easy for you guys. So for this particular part, all I really have to do is pick an end mill, and that's it. It's going to machine everything off for me. Now, if I want to fine tune it, I can, move this down to level 7, and we can go from there. With that being said, I'm just going to do a quick save and calculate here. And what it's doing right now is it's looking at the stock, looking at the target or the SolidWorks model, which is the same thing here, and it's figuring out where all the extra material is and where it needs to machine. And there's a huge amount of science going into this. So as we get into the tighter corners, well, let's just start with the open area. With the open areas, we're going to do a morphing spiral. Now, as soon as that cutter gets into a tight corner, it's automatically going to switch over to a D-slot tricoidal movement for you. And that's so we don't over-engage our cutter. And like I said, guys, I know some of this is a little bit of repeat from last week, but what happens right now is when you guys get into those square corners, you'll get a little bit of a chatter, not a nice finish, get a little squeal going on, and that's basically because we're over-engaging our end mill. Now, with iMachining, you'll never over-engage the cutter, and once this is done calculating here, I'll show you the maximum angle of engagement that we're going to use and the minimum angle of engagement that we're going to use.
Yeah, and Kevin, that's a really good point, because when you talk about that specifically, when that tool, like in a traditional, like say pocketing toolpath, where the cutter goes into the corner, you always see that sort of, you hear that familiar squeak, and then that chatter or that sort of like wavy pattern that you see in the corner. You'll never see that with iMachining, because again, like Kevin mentioned, we're always managing the engagement angle of the tool. So you'll never experience that with other well, you'll experience it with other tool paths, but not with iMachining. So there's a lot of different kind of science that's going on behind the scenes when you see this. It's very it's really very interesting when you kind of break it down into its.
Absolutely, and the best part is, guys, you guys don't have to do a single thing. It's all done for you.
Exactly. Yeah, it's nice. It's kind of nice when you don't have to think about it.
Exactly. Yep. So right here, just doing a zoom down spot where we're getting into a tight corner here, and I'll kind of move my mouse cursor around and just kind of show you guys what's going on here. But as we're doing a morph spiral, and now as we get into this corner, it's automatically doing like a spiral, working its way in there, just slowly munching away at that corner. So if I click on my view 2 right here, you'll see my maximum angle of engagement is going to be 70.8 degrees and a minimum angle of engagement of 18. So that's the maximum that we're going to go. Now, if you want to increase that, we can definitely increase that, but that's as it sits. Now, we can always go faster. So if you guys are running level 8, we need to go faster, you're going to go to your modify cutting conditions. Now, right here, you can have the checkbox turned on for turbo mode. Now, what turbo is going to do is it's going to almost double your step over and getting that material out of there. Now, if you guys are running, aluminum, even some of your mild steels, and you have a good vise, a good tool holder, you guys can run turbo all day long. So just keep that in mind if you guys need to go faster. Now, if you guys need to go even faster yet, we can come in here and change our chip thickness. We can speed up our feed rate and all that stuff. So real easy to use. Now, if you guys are noticing, I think I went over this last week too, if you guys don't have this modify cutting condition tab, let me just show you where that is. So what you guys are going to do is go to your SolidCAM settings. and we're going to go to iMachining and turn on the advanced cutting condition. And that's going to be your spot where you can see that. And then also right here, you guys do have the option to have a default material. So every time you guys start a project, it's going to be defaulted to, maybe your 6061 T6 aluminum or your 304 stainless, or, whatever you have. And this drop-down list is the same drop-down list as you have over in your iMachine data. So, okay, so you'll see that just by picking my tool, I have completely machined this part all the way up. Now, if I go into a little bit farther here into the technology, you'll see that it automatically put a wall offset and a floor offset of 15 thou in there. Now you guys can change that if you guys want this default number to be, let's say you guys always want it to have a default of 5 thou in there. We can definitely change that for you, and you just save it out as a template and load that template. And we can kind of get into templates, but if you guys go to the KevCAM YouTube channel, and you'll see where I talk about templates and then how you can set those up too. So, okay, so let's play this through. I'm going to do solid verify here, and I'm going to turn, okay, accuracy is good. So it's starting on the outside, working its way in. Now you'll see that I picked prismatic, but it still picked up that 3D surface. So it's kind of nice for us on specifically, for this part. So it is picking up that 3D surface for you, getting that material out of there. But it's also cutting our entire 2D part here using the 3D iMachining. We're getting that side here.
Ken, sorry, Kevin. I was working with Ken earlier. My apologies. So, but no, Kevin, another great point. When you talk about 3D iMachining, that's kind of a little bit of a misnomer. The 3D iMachining strategies can really apply to a lot of the the 2D prismatic parts that you may have. So, it's very worthwhile looking into this particular module, and because again you just gain so much more control over the toolpath, and again it's actually very inexpensive to to migrate to this particular module as well. So
yeah, it's like I said, it's even though it says 3D iMachining, I'm constantly using 3D iMachining on my 2.5D parts just because I don't have to pick anything. All they have to do is pick a tool and it's done.
I know. That's the whole, that's the coolest part about it too. It's like, it's pretty much fully automated,
yeah.
Right? I mean,
yep, absolutely. But now you guys will see that I actually just wiped out my vise, which I forgot to turn on for you guys. So what I'm going to do now is, with our new feature that we have added in there under the geometry page, I'm going to turn on my fixture collision, and I'm just going to do a clearance of 5 thou, not 2 thou, 5 thou. Now you'll see my toolpath, let me kind of get this rotated around here, is currently going through my vise. So now if I do save and calculate, it's going to update it, it's going to see that vise there, and it will avoid it, which is a real nice feature. You guys don't have to go into your working area anymore or do anything like that. The same goes for your tool holder. Let's say you guys have a deep pocket, but you just run in a short stubby. What we can do is turn on the fixture or the holder collision, and I'll show you that as soon as it's done calculating here, and it will automatically adapt for that the holder of your cutter, so it's not going to run into the wall. So you'll get, if you have a long, deep hole or a pocket, it's going to do a taper all the way down to the center, so it's not hitting that tool holder for you guys. So really cool technology that they have put in here, and this is all based off of you guys sending requests into us on what you guys want to see in there. So, like last week we were talking about iRough plus finish. That's the best way we can succeed at SolidCAM, is listening to our customers and listening to you guys of what you say, and putting that into the product right away. So, okay, we're about done calculating here. Okay, so now you'll see that we're not going through the fixture. Let me just kind of pan it around and get a better view here. So we're completely avoiding that fixture right there, going up and over it. So which is really nice. Now, if you guys are using like toe clamps on your part, that comes in huge. It's really nice to have. So any questions on roughing this out? Okay, we got clearance. How much will it avoid the fixture if my part isn't exactly the same spot? How does it know where the fixture is? Do I need to probe the fixture? Okay, so what Clarence is asking is, how does it know exactly where the fixture is? So when I put this part in here, I just mated it up. Basically just did a with mate and mated everything up to my fixture. What it knows is my fixture, when I picked it right here, do define. Right here, when I picked my fixture, and we can kind of go through how to pick a fixture here, but I'm just going to grab that jaw, my main vise body, my other jaw. If you guys want, you guys can put your bolts in there. Get the front piece. And by telling that that's the fixture, it automatically knows where that fixture is, and it's all dependent on where you placed it. So if you guys aren't, 100% sure, definitely move this fixture clearance up to, something larger if you have a little bit of slop in there and positioning your part on your fixture. So does that kind of answer your question, Clarence? Okay, I think so. Well, Clarence, if not, let me know so I can go into more detail for you.
Well, and Kevin, not to interrupt you, but just wanted to kind of, let people know if there are things that you kind of want to see a little bit more in depth, and something that's either shown here tonight or even just an example of a part file that you might have that presents a bit of a complex problem for you. Just let us know. I mean, give Kevin a call or email me or email tech support. We'd be more than happy to take care of those those issues for you. So don't be afraid to just let us know what you have. We're very open to that. And I'm not sure if we lost Kevin.
Sorry.
Kevin, are you still with us?
Sorry.
Okay.
I had myself on mute to take a drink of water. Okay. I don't know how
come on. I mean, dude, there's no breaks here.
Yeah.
You have to just get through this.
As my kids are hacking and coughing, I'm trying to stay healthy. Okay, so I don't know where I was here, but so that's kind of showing how the fixture collision works. Now, if you guys go over to your tool, you actually have the holder collision, which is the exact same thing as the fixture. So it's going to look at your tool holder, and long as your specifications of your tool holder, so we have a outside holder length of 1.5, long as that number is correct in your machine, that holder will completely stay away. Now we can change the the clearance of that holder too, so you guys can, it's fairly large right now at 290 thou, but like I said, if you're 100% sure that that tool is measured correctly and everything, you can turn that holder clearance down to 2 thou, and it's going to get, that holder will actually get within 2 thou of your material. So real nice feature, and like I said, it's real nice to have that in there for those really deep pockets, on a 2D or a 3D surface. So now, one thing I did cover last week and kind of forgetting to cover in this week here. So with your tool, all we did is we just told it a 1/2" end mill. We have our total length, outside holder. Number of flutes are extremely critical. So we need to know the number of flutes to calculate that chip load. Now, you guys are used to coming in here and putting your feed rates and all this stuff. Don't even worry about that anymore. All you care about is our topology page. So we have our diameter, in our total length and number of flutes, and then just come to the iData tab, and what is that end mill made out of? Premium carbide is going to be like your coated carbide end mills, TIN, the NIC coated end mills, and then the helix angle. Now, if your helix angle isn't in here, just go ahead and type it in. And we had a great question last week. I can't think who said it, but they asked it, what if you have a variable flute end mill? Now, if you have a variable flute, go for the middle of the road. Find the middle number there and just type that number in there. So, and this is really based off of the ACP, which is the actual contact point of that cutter. And where you guys can see that is on the Technology Wizard, and you'll see that we have a 1.0 of ACP for the first initial cut, and then we have a 0.6 ACP for the second cut. Now, if I came in here and changed my cutting length just to 1.5, hit the green check mark, now you'll see we're taking it all in one cut, but we have an ACP of 1.6. So now with the colors, sometimes it gets a little confusing for some people. So the colors are just to help you guys out. That's letting you know that, this cutter is going to cut this part without an issue, but there is a better one out there. So let's just play around with the tool just a little bit here. So we have a 1.6 ACP, and then we're showing yellow. So now if I come over to my iData and change this to a 45-degree helix, let's go to our technology with. See how we have it turned green on us now? That's telling us that is a perfect tool for that cut. And it's all based off the ACP, so the actual contact point of that cutter. And it's basically the flutes engaged into the material. So like I said, you guys can try to achieve to get green all the time, but you're not always gonna. And if you guys run across a cut that turns red, it's still gonna work. It's just not gonna be the ideal cutter for that particular cut. So if you guys have that 1/2-inch end mill sitting in the toolbox and that's the only one you have, run it. It's gonna run just fine. It's just not gonna be the ideal cut for that one. So, and
hey,
yep.
Kevin, as we're going through that, we did get another question. Is if you enter a wrong number, like so, for instance, like he said, does entering a wrong lower level data affect the way that 3D iMachining works?
Well, the levels, if I
yeah, I guess he's mostly maybe thinking about collision avoidance. So if you set something deeper than what it recognizes, does it affect the way that it works?
It's only going to
actually processes it.
Let's just go 2.5 for a depth right now.
Cool.
And that will kind of clear it up a little bit. The algorithm is going to be built just to go deep enough into the material for that cut. So if I remember correctly, we shouldn't be cutting through our vise at all. But we'll see what it comes up with here. And I know it won't, just because I forgot that I had that fixture clearance on there. But the nice thing, guys, is you have the solid verify. Use that as much as you can, because it's going to show you if you're crashing in your material. Same thing with the machine sim. It will show you when you're actually, machining through a vise or whatnot. And for the floors, so like right here, we have a floor finish. It's not going to gouge into that material whatsoever. So you'll never have to worry about going, let's say this pocket is 1.5 deep here, but you told it to go -2.5. It's not going to go through that your SolidWorks model and gouge or I'm trying to think of the word. I'm trying to think of here. Violate the boundaries of that floor level. Is that what you're kind of asking there?
Yeah, and I think that's what he was asking for. If that wasn't the right answer, certainly just let us know, and we can certainly open that up a little bit more. So
yeah.
just let us know if that answered your question. If not, we'll certainly readdress it.
Yeah. So you'll see we are going deeper on the sides now, but we're still coming right down to the floor of our material, so we're not violating that floor finish whatsoever. So, and you'll never have to worry about any of our operations actually gouging into the material unless you're using HSS, and then for HSS we do have the gouge protection for that. So, okay, so we have this part completely roughed out now. We still have 15 thou under wall and floor. Now we can change this to a smaller number, or we can put it at 0, and then we're still going to get good tool path there, but we're not going to have an ideal finish. So there's 2 ways of going about this. I'm getting ahead of myself here. One other thing I want to show with 3D prismatic, and it's going to be the same for 3D prismatic or 3D general, is let's say you guys don't want to machine the entire part. You just want to section it off to a certain area. No problem. Just click on the working area, hit the little checkbox for working area, and just define, the specific area that you want to work on. So maybe it's just half of your part, or a certain area that you wanted to use 3D iMachining. That's going to be the place to come to limit it to the specific area. Okay. So now we have that part completely roughed out. So now we need to come back and finish our walls and our floor and get that nice pretty floor finish. So what we're going to do is I'm going to show you 2 different ways. First I'll do the iMachining, and we can use our 2D iMachining for this. And we'll just do our constant Z propagation. And unfortunately I am going to have to chain these. Chain direction does not matter, which is really nice. Now, I don't remember if I talked about this last week, but right now you'll see that we have 9 chains in our list. So now what I have to do is I have to come back and mark some of these as open edges. With the SP3 that's coming out, it's automatically going to know if those edges are open for you guys. So really nice. You guys don't have to go back and mark open edges anymore, or like I'm going to have to do right here. Basically, it's going to know it just by your SolidWorks model. So, but unfortunately, I don't have that one right now, so I'm going to do mark open edges. And we got an open edge right there. And we have chain 9, mark open edges. And by marking that open edges, it's telling it that it can come in from that open side and go past that. And we'll go to chain 5. And we have all our open edges done, so we can hit the green check mark. We'll grab that same cutter. Levels, don't care about. And Technology Wizard, we can run it at level 6. Now, under the link, we are going to do the, I need to change this to iFinish. And when I change this to iFinish, I'm going to come over to the iRest tab, and I'm going to use my 3D iMachining that I did before. So by clicking my parent operation, it knows that it's already been all roughed out, and it's just coming back to clean up the corners and do a nice floor finish for us. Okay, so now we're coming in, cleaning up those corners, and what it's going to do is it's going to do that D-slot trick code, getting that material at first on all 4 corners, and then it's going to come back and do one nice smooth pass all the way around. Now if we want, I can come in here and do a floor. And now we're doing a floor finish for all these areas. So real nice, get that pretty looking floor finish. It's finished all the way up to size. So we just roughed and, oh, actually I forgot to chain that whole entire inside. Let me add that one in here. We'll just blame that one on Brendan.
Well, I mean, naturally, it's always my fault.
Okay, so now we have a nice, pretty finish in there, getting all that material out of there. So, and basically, if we let's just kind of do a recap. So what we did is we told it what material we were using. We told it what CNC machine. We did a 3D iMachining and just told it what tool to use. And then we did a 2D iMachining to finish up the toolpath, and unfortunately we did have to pick the geometry and just to pull up the old geometry from the iRough and finished off that part. So real easy to use, and that's kind of what we're shooting for here is ease of use. And I really want to show this to you guys on a 2D part first, kind of where we left off last week, and then now we'll get into a 3D part. But do we have any questions so far on this part? Okay, we do have.
Yeah, so far. Yeah, I was just going to say, Kevin, he said he ran into an issue earlier this week when you use a larger end mill to finish than what you use to rough in iMachining. It throws an error. Is there any way around this?
So you used a larger tool. So let me just
then what you use to rough out. That would make sense because, yeah, so there would be more material. He might be thinking about either pencil machining or finishing.
Yeah, so I think this is the is this the error that you're talking about, George?
That could be it.
Yep. Okay.
Yeah, you did.
So what's going on here, George, is it's telling us that we're coming back with a larger end mill, and that larger end mill won't be able to get into those corners like it's supposed to. And by picking that larger end mill, we're going to have material left in those corners, and it can't clean it up, and that's why we're getting that alarm. So stick with either that same size cutter as you're roughing, as you're finishing, or what we can do to get around that is just do a standard profile operation, working our way around using the same feed rates as what is being calculated here. So if you want to use that, like right now we're getting the error, but come in here and I can just copy this feed rate out and this RPM out and just do a one profile line going all the way around. Could we finish the center hole without air cutting? Yeah, absolutely.
Yeah, I just was telling that particular guy we're just going to get to that question. So, yep. If can you kind of address that now, Kevin? Or
yep, you bet.
Perfect.
Okay, so you'll see the center we are doing air cutting in there. That's just because I just saving time just chain that. But what we can do here is chain this guy and mark that chain as open. And now that eliminates all the air cutting. So basically just kind of going through and it knows that this material is missing and it's just dropping straight down in and doing a morph spiral working its way to the outside, and that's how you do that, Carlos. Okay. And same thing for the outside. You'll notice that I didn't do iMachining on the outside doing the finish pass in there, but exactly the same thing is what we did before. Is you just click on your stock right here and mark that chain as open. Okay. Any other questions before we get on to the 3D, or is there something that I'm not covering here that you guys want to see?
Oh yeah, no. It seems like everything is pretty much spot on here, Kevin. Looks like everybody's pretty much on board. But okay. Again, just a reminder, we're a little more than halfway through here. So again, please feel free to type in the questions. We'll get those answered, and as we move on to the next part of this, we'll again we'll make sure we get these answered. So
absolutely.
No problem.
Okay, so we have a very complex 3D part here. A lot of different surfaces and whatnot here. So what I'll do is I set this up on a Herco. Oh, let me see if I have a Haas UMC in here. No, I don't. I'll do Haas 5-axis. Okay, using H13 material. So I have my material set up, got my machine set up, hit the green checkbox. And now what I'm going to do is, and I've added, I've kind of went ahead and added my fixture in here and did a machine setup so it knows, you know, if I go into the machine setup here, you know, I'm using my clamping fixture. And, you know, if you guys aren't sure how to do a machine setup or setting up your fixture, definitely come in here and just type in fixture, how to use fixtures and machine setups. Quick little, you know, minute 42-second video on how to add those in there. So, and if you guys are a little bit new with YouTube, if you guys come to my channel and you guys have something that you're specifically looking for, don't do the search up here. Just come to my channel and then use the search icon right here, and this will navigate you to any of the videos that I have created in the past. So it's a great search engine to view previous videos. So if we want to do shape tools, I can just type in shape and it tells me exactly how to do a shape tool right here. So, okay. So we got our part. So we're going to add our 3D iMachining here. Basically, I'm going to just leave it on 3D General. I'm going to grab my tool. And we have, let's see, 375. Yeah, let's use that cutter. Don't really care about levels. Come to the technology wizard. Let's run this at level 7, and we'll run turbo because we really want to see some chips fly. So you'll see we're having to take this in not 3 steps when it's at the full depth of cut, which is a ACP of 1.7. And I can change that, you know, if I want to use a different flutes, but this is the only end mill I have in the shop right now, so we're going to run with it. Save and calculate. Now, in here, what it's going to do is it's going to rough everything out all the way up to 15 thou, which is our default number for the wall and the floor. Now, if I wanted to change that to a smaller number, we definitely can, but we also have full control over our scallop. Now, the really nice thing about 3D iMachining versus every other CAM system out there, even HSM or HSR as a roughing operation, is what we do is we maintain a constant scallop height, where all the other programs out there maintain a constant step over. Well, the only problem with that is let me just do a simulate here, do a solid verify, is we're actually doing more more cutting than what needs to be. And we'll run this through real quick here. And I don't know if you guys noticed, but I mean, all I did for this part is just pick the tool and I turned my level up just a little bit faster. So it found my SolidWorks model, found my stock, and it's machining everything off in between right now.
Hey Kevin, can you talk just real quick? Can you back up that simulation? Do you see where that there's that boss, that round boss, and then there was like it was sort of like it was coming right through on that pocket. Can you back that up just a second in the simulation? Because there was something really cool going on there that iMachining does, and you know. It might seem a little bit insignificant, but it really means a lot.
Okay, you tell me when to pause it.
Sure, yeah, no problem. So we're going through, yep, it regionalizes, and then, so it's, yep, keep going there. It's actually on the kind of the left hand, right here, yeah, as it goes through. Watch what it does as it's, all right, do you see how it's coming through right there, that where that round boss is? And so a lot of times in regular toolpaths or you know, most of the time what you get with normal or you know, kind of conventional cutting, where it breaks through that wall, a lot of times it just continues at the same feed rate, and then all of a sudden, you know, it'll the end mill may, you know, the tooth might catch on, you know, that particular side, and you could get a breakage, like a tool breakage there. But iMachining is smart enough to know what's already been cut. So what it'll do is it'll actually slow the feed rate down, but still maintain that chip thickness in order to break through that wall. Did you see what I was kind of talking about there, Kevin?
Yep. And
yeah.
That's what we call
maybe you could explain that a little
yeah.
a little bit better than I could.
What it's doing is, what Brendan is saying is, iMachining adapts for thin wall features. As soon as it knows that it's getting into a thin wall, it actually changes the feed rate, and it's going to change the approach angle of that end mill, so we're not breaking through. And as you guys are breaking through a thin wall, you get that little piece that's going to curl around. And a lot of times it's not going to break an animal, but it's a good spot to chip out a tooth, or not get a nice finish, and that little tiny slug is going to wrap around into itself. Well, with iMachining, what it does is it accommodates for all that, and it's going to automatically slow down, like Brendan was saying, and it's going to change the approach angle of it. So, like right there, as we're getting through, let me just, and we might not even actually machine through here because our end mill might be a little too large, but right here we have a thin wall. It's automatically going to switch around the feed rate for you guys and approach it with a different angle of engagement, so we're not having that little piece or that little slug curling back behind itself, and then when we come to take that second cut through there, it's getting rammed into the end mill. So yeah, great point there, Brendan.
Yeah, no, it's just it happens all the time, especially raised bosses and things like that. You have to, there's really no way to accommodate for that in most other systems. But iMachining is smart enough to realize what material has already been removed. So, it's just those tiny little nuances that that make the difference with our system.
Absolutely, yeah. Okay, so we've got this part completely roughed out here. Now, what we're talking about scallop height is, you'll see my vertical wall right here. If you guys are seeing my mouse cursor, this particular one right here, you'll see that it looks like my steps are much farther apart versus over here. Well, what it does is, like I said, it's maintaining that scallop height. So on conventional systems, you're going to have those same amount of lines no matter what, but that scallop height is actually going to be much smaller than what it's supposed to be. So by doing it this way, we're saving machining time, but when we come back to do a finish pass on here, that load and unload of that ball end mill is going to be same throughout the entire cut. So on a more vertical wall, let's say the old way is these scallops would be much smaller, so you're going to get a different finish versus over here where that scallop is going to be that specific size. So it's one huge advantage using iMachining over everything else. And I'm not comparing to SolidCAM, any of the other CAM companies out there. What I'm comparing it to is like HSR or HSM or HSS, which is the same module that all the other CAM companies use. Is that scallop is going to be the same scallop height throughout the entire cut using 3D iMachining. Okay, so
yeah.
Oh, good.
Oh no, I was just going to say no. I think I kind of understand what you're saying. I mean, basically that that distance when Kevin was showing, if you could draw a straight line across that particular scallop, that the distance or the depth of that scallop is going to be consistent across the entire surface.
Yep.
So it really kind of eliminates the need to do like a semi-finish or anything like that. So, and again, that's the power of iMachining. You can do a roughing toolpath and then just do a finish right over the top of it because, again, we can control all of that, that scallop data, and it saves you just tons in not only programming time, but cycle time, because you don't have to do a semi-rough, or I'm sorry, a semi-finish pass.
Well, and then also when you're roughing it out, you're not really air cutting anymore. You're
exactly.
keeping that scallop height the same. So
sure.
Okay. Yep. Now, if we get into the guts of things, here is where my scallop is. So my scallop is defaulted to kind of a goofy number here, but let's say you wanted a different scallop. You want a nice finish. So what we can do is we can change that scallop to like a 30th scallop. We'll save and calculate that. And then right here too is guys can change your cutting angles. You guys are not locked out of any of the iMachining stuff. To get some of the stuff to turn on, you might have to turn off the wizard, but you're not locked out of any data. So we had a great question last week. The most that you will ever be able to engage a cutter is going to be 80, I think it's 85 degrees. Well, this particular customer wanted to go farther, 110 degrees. And this is where we can change that, the angle of engagement. So you're not locked out of it, but you're not going to have the wizard backing you up with the correct feed rates just because we're over engaging that end mill. Okay, let's get some toolpath here. And I might have to simulate this just so you guys can see the difference. And I have my simulation turned up as fast as possible so you guys aren't having to sit and watch this play through here.
It's actually kind of fun to watch these things. As long as it doesn't touch the vise.
Yep.
Which, none of us have ever done before.
Yeah, right. I still have marks on my some of the vices where I used to work.
I don't know. Should you share that video, Kevin, of when you were snowmobiling the other day?
Yeah. I was telling about that last week. You guys won't be able to see it on the YouTube channel, but they were talking about in my videos. Right here, I got a video. It's locked, but so you guys won't see it on your end. But walking on or snowmobiling, going across open water, and she didn't quite make it, unfortunately.
Yeah, Kevin basically almost died. So,
but hey, I got it on video, so it's.
You do. It's
made it all worthwhile.
Thank God you didn't. Because I mean, I don't know if I could run KevCAM for the rest of my life.
Okay, so you guys can see we have a much smaller scallop height, getting that roughed out in there. So real nice. And here's a good spot. Let me just do a side view. So right here you can see our scallops, are all uniform, kind of going up this surface, but when it gets around those straight up and down edges, it's much farther apart. And like I said, we were just talking about that, it maintains that scallop height throughout the entire cut. So, okay, so what we're going to do now is, I suppose I should let this play through here. And what we'll do now is we'll actually come back with a smaller end mill. And the only reason I'm coming back with a smaller end mill is just to show you guys that you guys can use basically the iRest in 3D iMachining, even though that it's not even there. Okay, so we got that one done. So what I'm going to do now is I'm going to do a save and copy. Or do we have any questions on 3D General or any of the options inside 3D General?
Well, not so much any questions, Kevin, but I think we've got a really great feature request that came in from one of our attendees. So okay. If you want to continue on with what you're doing, and then maybe we can address that at the end.
Sure, absolutely.
And again, like you said, when there's a feature request and it's in, there's a little bit of a, care package that comes along your way. So, but this sounds really kind of cool. It's a great suggestion. It seems like it'd be pretty easy.
Sweet. Okay. So now we have our 3D iMachine. Now what I want to do is come back with that just a little bit smaller of an end mill just to get into some of these, tighter spots right here. So I can keep that operation open, and I can do it the save and copy, kind of like what we went over last week. Now what I'm going to do is I'll switch it over to that smaller tool, and you will just use the 1/8 inch cutter here, hit the green checkbox. Now what it's going to do is it's going to pick up any unused or any material that was left over from that. I think we had a 3/8 inch cutter in there. So right now it's updating everything kind of behind the scenes for you guys and calculating all that toolpath. So we'll just let it calculate up here. Now, one thing I forgot to kind of go over a little bit is sometimes you guys will get additional toolpath on top of toolpath that was already done. And what's actually going on there is it's more of a tolerancing of two tolerances coming together. So, we're talking, from that 3/8 inch end mill, this, 1/8 inch end mill is going to pick up. But if there is, 1/1,000,000th there, it's going to pick that up and it's going to kind of recut that. So to get that so you're not kind of recutting the same material, as you guys can go to your wall offset and increase that wall offset. Instead of saying 15 thou, you can say 16 thou, and it will leave that 16 thou on the wall, but it's not going to recut anything that was cut before. And like I said, it's more of like a tolerance. We're going out, several decimal places, but those decimal places go on forever. So if there's any little bit that was left over, it's going to pick that up and try to remachine it.
Yeah, and Kevin, that's fair enough. I mean, it really does depend on, what type of accuracy you're looking for. I mean, if you're saying, okay, well, I can do a little bit of handwork, or I don't want to do any handwork on this, yeah, it really does kind of depend. So, the tolerancing is, that's sort of it's funny because a lot of people ask me that too. When we do product presentations, they're like, well, how long does it take to create that toolpath? Well, it's very dependent on what you want to see for a surface finish.
Yep.
So that's a great point.
So you'll see that we're getting quite a bit of toolpath, a little bit of recut going on there. So now what I can come to my technology, just switch this to just 1 thou bigger. And I can already tell my calculation time is going faster.
Well, and the cool part about this too is, Kevin, I know you're not using anything super, crazy for a computer, right? I mean, it's pretty much a laptop, right?
Yep. This is actually a Dell. This is actually a pretty old laptop. It's a Dell Precision 6800. If we want to go to
a lot to be said about that. Well, you don't even have to show. I mean, it's totally fine. But I'm just trying to make a point. I do a lot of presentations with Ken, obviously, which I mistook you for earlier in this presentation. And I apologize for that. But Ken actually runs a Surface Pro 3, and he has tremendous results with that. So again, just really kind of speaks to the optimization and the proficiency of our development people and what we can do. So you don't have to have a powerhouse computer.
Yeah, and it kind of same goes for your CNC machine. You guys don't have to have this high-end, super powerful machine.
Exactly.
We talked about this a couple of weeks ago. Is you guys, this will run on your old outdated Haas mini mill or your Easy Track machine. So we're getting material removed out of there as fast as possible, but we're utilizing your machine, and it's not going to. We're never going to with the parameters of that CNC machine that we put in there, the horsepower, the max feed rate, and the RPM. We're not going to overdo your machine. So.
Yeah, Kevin, another great point. That's the whole thing. What we want to do is we want to make you more productive with what you already have. You don't have to go out and buy a $500,000, high-speed machine. We can take your, like Kevin said, you wouldn't believe some of the production that we're getting out of, an old, like Kevin said, like an old Bridgeport, machines that are older than I am, believe it or not. And I'm not that old, but I just, again, it's just really, it's amazing. Again, it's just because you're programming in a different manner. That's all it is. iMachining makes all of the difference in the world. And it doesn't have to be 3D, 4 and 5 axis programming. 2-axis programming. It's just the approach that we take with the way that we produce toolpath. And again, challenge us on it. Call us. Kevin would be happy to program all of your parts for you. There you go, Kevin.
Hold on. Let's not get too carried away there.
Hey, look, I got to throw it out there. I just want to see how far I can take it.
I do like to have a little bit of sleep during the night.
Well, that's true.
But okay, so we're doing
little kids.
Yeah, we're doing some, just doing the finishing touches there. Just kind of want to show you what it kind of looks like in Machine Sim for you guys. But is there anything that I'm missing, guys, with the 3D iMachine, or is there anything that you guys wanted to see that I'm not covering with the settings, or anything at all with what we're doing here?
Kevin, I think one of the things that I'd like to address, there are a couple of, well, there's actually one last, two questions. There's one that says, going back to the advanced parameters, as a feature request, I would like to see the ability to specify an angle of engagement of, say, 120 degrees, so I could use a face mill with 70% engagement and still have the benefits of stock recognition and fixture avoidance.
Sure.
Even with the wizard turned off. Is there a way you can show that?
Yeah, so we can do maximum, do a minimum angle of, let's just say 80, and a maximum angle of 150 degrees, right there.
Perfect.
So to get that, all you have to do is just turn off your wizard, and then you can type those into values in there. So I don't want to save and calculate right now because it will do a little bit of time crunch in there, but that's where you basically go, is come to your technology screen, turn off your wizard, type those numbers in. Like I said, for the face mill, it can definitely handle much more, and then you guys don't have to worry about selecting geometry or your collision avoidance like you're talking about, and then turn it to 150 degrees. So absolutely.
Perfect. Excellent. The next one, Kevin, is the Kurt Weiss model available by download from Kurt, or where can I get that?
Let me show you guys. This is one of my favorite websites, 3D Connection. Or 3D
I know
Content
you love
that. So if you guys go to 3D Content Central, and let me put the link in there for you guys in the chat. This is a SolidWorks sponsored website. Has tons and tons of models in here for you guys. So Kurt Weiss. I can come in here. I got some vice jaws. I got the little movable stop. I have the full Kurt Weiss. I have the full Kurt Weiss without a handle. So
fantastic. That's so great.
All the stuff's in there. So I know a lot of people use the Chick Weiss. Chick Weiss. Let's see what comes up for Chick Weiss. Oh. No. I think I spelled that right.
It's C, not S. There you go.
Oh, what did I spell it?
You said Vice, V-I-S-E. It's V-I-C-E.
Let's see. Good old Google here. Chick.
Now, that's really funny, kind of funny. There's a certain scene from TED 2 that I could bring up in this meeting, but I certainly will not. So, moving on.
Okay, so here's Chick Weiss. Oh, I probably spelled it wrong. I'll just do that, and okay, so we get a little bit of, boy, I'm surprised they don't have Chick Weiss in there. But yeah, here's where you guys can come and get a lot of. Actually,
you know what, Kevin? It's C-H-I-C, without a K. George Lauer, thank you for that. I appreciate that. It's C-H-I-C.
DHIC. Nope, still nothing in there. I'm surprised there's nothing in there. But you know, there is tons of stuff in here. If you guys are looking for nuts and bolts, also toe clamps. So you got a bunch of different toe clamps that you guys can import in here. Mighty Bites are all in here. Another great website to go to is McMaster Car. And you guys can come in here and let's say you guys are trying to find a bolt and socketed cap screw, and we're looking for a 1/2-13 1-inch long thread, and that should be good enough. I can come in here and click on the part model. Let's see, do product detail, and I can actually save out that SolidWorks model. It'll actually download the SolidWorks model for you for your bolts. So real nice feature. And the 3D content with the can't think right now. The check vise has definitely been since I've been doing the night class has been a popular question. So definitely 3D Content Central is the place to go to get your Kurt vise.
Excellent. Another question, Kevin. When we edit a previous operation in a CAM tree, the 3D iMachining operation needs to recalculate, but the other model or target-based operation, such as 3D HSM, doesn't ask for it. Can you describe this?
Okay, so if we change something right here, what it's going to want to rebuild, and the reason why HSM or HSR or HSS isn't going to come to that point is because we use, with 3D iMachining, we're using much tighter tolerances. And to kind of go over the tolerances, if you guys go into your settings, and let's go to updated stock calculation, click on rest material, we're doing an accuracy right now of 1 thou. This 1 thou, I would never go over 4 thou, but this number kind of correlates with your stock facet tolerance, which is 1 thou right here. So don't go over 4 thou, but the reason why we're getting that calculation for, or popping up that it wants to rebuild, is it sees that something has changed down to the 0.000001, and it needs to update, and that's why it's asking you to do a calculation on there. Now, technically, I shouldn't, on like this particular one, if I change this to, let's just do a 17 thou, and 17, and I'm going to turn off this. So calculates a little faster. It shouldn't break what's up above. And what I mean by breaking, or what he's talking about there, is you'll get the little asterisk mark there, or the little star, and that it's just asking you to recalculate it. So something has changed very minutely, and it's wanting to pull that data back in. So hopefully that answers that question.
Sure. Yeah, and Kevin, no problem. And the other thing, we could always take these offline. Of course, anybody can call any of of our tech support guys at any time. I think the last remaining question was from Jeff in regards to his previous question, and something about, again, the with the wizard turned off, the tool path will not calculate with an angle over 80 degrees. I think maybe what we should do is maybe take this offline and talk a little bit more about that, because I think there are further questions, Kevin.
Okay.
And so, but Jeff, please let us know, whatever questions or concerns that you have. We'd be more than happy to address those.
Yeah, and like I said, by turning off that wizard, then that's when you can basically over-engage your cutter like in a face mill. But if you have a specific part, Jeff, that you're talking about, shoot me an email, and we had a meeting right away in the morning. But anytime after 11 o'clock Central Time, let's take a peek at your part and look at what you're trying to achieve there. If I go back to, let me close out of here. and I'll try to replicate what a couple of you guys were asking for here. Let's see, recent parts. Let's say I'm going to delete that, yes to all, do a 3D iMachining, and we'll just go to our tool, use a face mill, and we'll just 1.5 face mill, number of flutes 4, green checkbox, levels, we'll just say upper level 10th.
This is what I love about Kevin. Like he won't give up until he finds the answer. It's so great.
Okay, so let's do 150 degrees and let's do 80. I probably should have just done this in a 2D, but okay, so yeah, let's do this. Let me delete that. Add 2D. It's telling me I don't have any material there to machine off, so we'll just tell it that it's going to machine off. Mark that chain as open. Tool select. Levels. Do upper level 0.01. Okay, so now we are, oh shoot, here, I messed up on my geometry picking. I'm going to just delete that chain 1.
I think going back to all of this, Kevin, you know, Jeff was the original guy who answered, or I'm sorry, asked the question, why won't it allow you to do it from the modify parameters page?
Oh, right
just
here?
To stump you a little bit further, you know, because you're good, you're awesome.
So if we do a max cutting angle of 150, I don't know, Jeff, I guess I would have to dig into this a little bit further. I don't know why it won't go over the 80 degrees right here with the wizard turned off. But maybe possibly that's why they put it in the technology section, to then you can achieve your, you know, your 150 and what to say 80 degrees minimum angle of engagement. But let me talk to our iMachine developer. Jeff, if you could send me an email on that, just because by the time I get done editing this video and uploading, I'm going to forget about it. So shoot me an email and I'll let you know why we can't modify it in the modify cutting conditions by hitting the checkbox versus coming over to the technology and manually entering it in right there. So.
Yeah, and that's cool. And, you know, again, you know, Jeff, please understand, obviously, this is, you know, this is more of a training session, but, you know, again, we're very interested in any suggestions that, you know, all of our customers have. So, you know, again, yeah, please just, you know, send an email over to Kevin or myself, and we will definitely address that. Not a problem.
Yep, absolutely. Thanks, Jeff. Appreciate that.
Well, okay. That's more directed to you, Kevin. That's not directed to me. So, well, Jeff, thanks so much for your patience. We really appreciate it. And again, thanks for everybody for hanging on. You know, we went over a little bit, but Kevin, did you have anything else you wanted to talk about?
Or? I just wanted to make sure we got everybody's questions answered, or if there is questions, now is the time to speak. But like I said, guys, you know, I do this night class, you know, solely for you guys. If you guys do have something, just like Jeff had something come up, please email me. Let me know. You know, if you guys are machining, you know, late at night and you guys run into issues, shoot me an email and I'll address it right away for you guys, as long as I'm within internet activity. So definitely shoot those questions over to us. You know, I want you guys to see this class. I want you guys to use our support and be like, man, that is the best support we've ever gotten. So, and that's, you know, that's our main goal at SolidCAM support is, you know, give you guys the absolute best service as possible. So.
Well,
right.
you know, absolutely, you know, definitely. So, you know, again, Kevin, thanks so much for your time. Everybody here, thanks so much for yours. I know it's tough to break away even when it's a little bit later in the evening, but, you know, again, please feel free, you know, let us know anything that you, anything you need. We'd be happy to help.
Absolutely, guys, and, you know, if you like the product, tell your buddies about it, and we'll throw you a $100 gift card, and if they buy you, we'll throw you 20% of it, so even better yet for you guys. So, and like Brendan said, thanks again for taking the time out of your night, and you know, if you guys do have suggestions, ideas, please email those over to us, and we will get those added in there. Nothing will be overlooked. So let us know what we can do to help you guys out. And like I said, thanks again for taking the time out of the night. And next week, I don't even know what I'm covering yet. I think it's HSM, but I can't.
Kevin, come on, you know,
can't remember.
You got to end on a high note like that. You know, you got to get them excited.
All right, so let's find out what's next week. I can't remember what I put in the schedule. Let's see. Go here.
You know, please tell me it's not like 2D pocketing or something.
No,
like
no,
that.
no. We're getting. We're definitely
really
getting into the
exciting.
good stuff. Where's my landing page? There it is.
Well, all I know is I'm going to be on it next week as well. So I'm excited to meet a new group of guys and see all, you know, all the other familiar faces that we have. So that'll be fun.
So next week is going to be 3D HSR. So kind of covering what we did tonight, but using HSR instead of 3D iMachining. After that, we're going to go to HSM. And after that, HSM is going to kind of be a series. For those guys that use HSM on a regular basis, you guys are going to know that there is a lot of options inside HSM. So we're going to kind of take these in chunks right here, just because there is so much in there. And I want you guys to understand everything that's going on just because there is so much here. And I want you guys to understand that as much as possible. So we'll be getting into that, and HSM is going to take us a couple weeks to get through here, but then we'll get on to HSS. So.
Very cool. And, you know, Kevin, just one last thing. We had a great suggestion, and in fact, I couldn't be more happy that this was brought up. Clarence Wilson brought up a suggestion. The regulars that come in here, make the classes a one-click register for everything, instead of having to go through and, you know, register their, you know, first name, last name, all that stuff. I mean, there are a lot of regular visitors here, and that's a great point. And Clarence, believe me, we will absolutely, and we're getting a lot of requests now for that, more than one. So message heard, guys. Thank you for letting us know that. We'll talk to the people that run the registration page.
Yep.
And we'll make this happen for you.
Yep.
Don't even worry about that.
Absolutely, guys. So we'll get that switched around. Jack will get that fixed up for us and get it so for the regular guys here, just have to click and it should be there for you. So, but I guess that kind of wraps up. And yeah, we definitely do have a lot of people that like that. So great point there, Clarence. But like I said, you know, any questions, concerns, let us know right away. And give me a couple hours and we'll get this uploaded onto the YouTube channel right here. And you know, like I said, let us know what we can do to help you guys out. And thanks again for joining us tonight. All right, guys, have a great night.
Thanks, guys. Take care.
Bye-bye.